Um, Sorry, let me get this out of the way. Good morning, everybody. My name is Willem Schreuder, AC0KQ, and I wanted to talk about CallMon. So many of you are probably familiar with AllMon. So in the Rocky Mountain Ham network, we have a number of clubs that use Allstar link as the connection between repeaters. So the Colorado Connection, CRA, NCARC, LARC, several other clubs all use Allstar link to link analog repeaters together. And a number of folks came together and wrote this really cool monitor program called AllMon that you can use to actually monitor your connections. So in particular, what it has is a dashboard that shows you for a particular node everything that's linked to it. And if somebody keys up on that link, you can see that that's where the audio is coming from. For voter systems, such as what the Colorado Connection has, it'll also show you the signal strength of all of the individual voters and which of those are voted. So in the image in the lower right-hand corner, you'll see here that Squaw is currently being voted, but it's also receiving from Thornton, Lee, Conifer, and Spire. And so in this particular view, you have to go into a different screen and actually to be able to see the voter data. So there was actually an update to AllMon called AllMon 3, but it was a bit of a disappointment because it actually separated out the voter portion completely. And so out of frustration, Chris, K0SWE, and myself started a new project called CallMon, which is what I want to talk about today. So what you see on the right-hand side is the CallMon display for the Colorado Connection. And the idea is that we wanted to display basically all of the information about the system all on one screen. So here, what you're actually seeing is a triple happening. So in the top right-hand corner, you'll see that somebody has keyed up on Thornton. You can actually see which voter receivers are being receiving. And so there's audio coming in from the hub on Thornton. Somebody also keyed up on Colorado Springs, and the voters there are getting a good signal, and that's feeding audio into the system. And somebody's also keyed up on Salida and transmitting. So, you know, we've got people talking all over each other. But you can also see here that it shows a little bit of a history. So the yellow bar shows the peak reading over the last 5 seconds, and somebody was on the Lyman machine, and it basically had unkeyed, but you still see what the signal strength was there over the last few seconds. The key thing here is that what we basically went about doing is to write a C server backend that will collect all of the data. And then what Chris has been working on is the JavaScript front end to the HTML displays that we can actually then run in a web browser and see the state of all of the repeaters, whether they're transmitting, whether they're not transmitting, whether they're sending telemetry and various other pieces of information. So the nice thing about this is that it basically integrates all of these displays into a single screen where you can see the total state of the system. We also wrote it to be distributed. So as you can imagine, there has to be a server that goes and talks to all of the Allstar nodes, and the CPU load can be quite significant because you need to poll Allstar and ask it for information. So the CallMon design actually allows you to run local instances of CallMon that collects this data, collates it, and then passes it up the chain. The other thing that we went for was minimal configuration. We didn't want to have another complicated system that you need to configure, so we integrated it well with the actual Allstar configuration files as far as telling the system about the data. And we also focus on private nodes. So the AllMon 2 and AllMon 3 actually relies on a public database for the information about the nodes. And since all of our nodes are private nodes, we needed to find a different solution to that. But the key thing is that we were looking for detailed node status on all of the nodes so that we can see how the system works. So the configuration is actually fairly straightforward. What this shows is if you're running an Allstar instance, you'd basically have the asterisk server running on the local machine. It'll talk to either the radio thin client modules or the USB connected devices to actually run the asterisk or the Allstar link servers. And then we also have this CallMon server that very often runs on the same machine as that Allstar instance. And that particular CallMon instance will obviously read its own configuration file, callmon.conf, but it will also go and read the configuration files that asterisk is going to be reading. And so the idea is that by integrating CallMon tightly with those Allstar configuration files, we can minimize the amount of configuration we need to do. So here's an instance of the CallMon configuration file. So you need to specify a login, so a username and a password. The password is not XXXXX. And then you give it a local name. So you basically tell it here that we're running a local instance. In this case, I call that Thor Hub, and that is its external IP address that you want it to talk to. The CallMon will then go and look at the iax.conf and the manager.conf files to actually figure out on what ports these devices are listening, what are the secrets to actually access the asterisk interface, the voter.conf to actually see if there should be some voters that we should be listening for. And then in the rpt.conf, which is basically the main configuration file, thanks to Mark and 7CTM, in the CallMon instances, there is this include if exists that sort of nicely wraps all of the settings for each of the nodes. But then you say it's an RX channel pseudo or an RX channel voter. And then this line with the semicolon exclamation is then the configuration to integrate this into CallMon. So basically the name on the left-hand side of the equal sign is a short name that we will use for menus to refer to that particular node. And then the longer name is the one that will show up in the tables that will actually show you what the repeater is, what frequencies it's on, and things like that. Why this works is that the semicolon line is treated by asterisk as just another comment. However, in the case of CallMon, it will recognize the semicolon exclamation combination and then say, oh, this is something that I need to pay attention to, in particular, what the node, the text definition of that particular node is. So in order to actually integrate this with the web server, what you can optionally do with CallMon is to actually run the CallMon CGI interface, which Chris has primarily been working on. And that's the interface to the web browser. That particular program talks to both the CallMon C server to get information about the node. That CallMon server will poll asterisks to get things like the node status, what's keyed up, what's the signal strength on all of the voters, and all of those kinds of things. But that CallMon CGI can also send commands to asterisks, such as unlink the node or link the node to a different node, things like that. The other thing about CallMon that's nice is that it will, in addition to talking to an asterisk node on the local box, it could also talk to remote asterisk instances. So you can use one instance to actually run several individual nodes, or it will talk to other CallMon instances and basically import all of the data from there. So we call those concentrators. So for example, if you have a club and you have several Allstar link nodes, each of them have a CallMon instance running individually, but you want to see your entire system, you can have a CallMon server that simply talks to all of those ones that actually run on the individual nodes, and use that to then view the whole system. So your input to the system is at a higher level than the individual repeaters. So here's an example. This is the Colorado Repeater Association CallMon. So on each of these 4 repeaters, actually there's more than 4, but you have a CallMon instance that's running on each individual site that basically talks to the local Allstar instance. But then we have a CRA CallMon concentrator node running at a central location that gives you a view of the entire system. So in this case, there's the VHF hub, and you can see at the current time, El Dorado is keyed up, and all of these other ones are basically transmitting the link audio, whereas, of course, El Dorado is in local repeat mode. At this time, the 145 on Squaw is running as a standalone repeater, but you can see that it's actually also in a local repeat mode. So it's receiving a signal locally and retransmitting it. What you can then, through the control interface, do is say it's the ClubNet. You can actually link this node into the rest of the hub, or make whatever connections you have. The nice thing about Allstar is that you can basically, any node can be a concentrator, or you can daisy chain nodes together. What this will basically allow you to do is to view the state of that particular system, as well as all of the individual standalone nodes. The reason for showing this, of course, is that in this case, these are all USB interfaces, so they're not voting, but CallMon works just as well with USB instances as it does with systems based on a voting system. So what we've actually done is to create a whole hierarchy of individual clubs that exist on the RMHAM network, and then combine all of these into a view of the entire system that we call Megamon. So the idea is that, for the example, for the Colorado connection, we have all of these individual instances that run locally. This really cuts down on network bandwidth, because the connection between CallMon and asterisk is actually pretty verbose. CallMon then concentrates those data into a much more compact form that then gets passed up the chain. So, for example, we have a Colorado connection or a CallMon that basically shows a view of all of the Colorado connection systems. I've just showed you the CRA version of that. We have a version for that for NCARC. For LARC, we have an instance that runs, but it all runs in one location. So I colored that blue instead of yellow, because the yellow instances are actually concentrators, so they don't have any local repeaters connected. They just collate data from other CallMon instances, whereas the LARC one actually runs the repeater itself as well. The advantage of doing this is that with Megamon, I now have a view of all of the repeaters that is available on the system. So if we have, for example, an incident where we now need to go and reconfigure the network. So let's say we want to take one of the CRA repeaters on Squaw Mountain, let's say the 145. We want to link that to the LARC repeater in Longmont, and we want to link that to the Buckhorn repeater from NCARC. What we can, from Megamon, have a view of all of the repeaters that are available throughout Colorado, and basically disconnect them from where they were connected before, and form a new cluster of connected repeaters that then can serve whatever instance we need to do. So, for example, on the SantaNet that we have in December, we can create an ad hoc group. But also, of course, in the case of emergencies, we can form an ad hoc cluster of repeaters that we can then tie together as a new linked repeater system. And so the part that I didn't demonstrate here is, of course, that control interface for how you actually form this. Well, that's actually inherent in Allstar, right? So in Allstar, you can connect any repeater to any repeater, and all that CallMon actually provides is a user interface for selecting individual nodes, disconnecting them from where they currently are connected, and then reconnecting them into a new configuration. It's typically convenient to select one node as the new master node and then just connect all of the other repeaters to it, because in CallMon you can then just say, show me that particular node and all of the links that are connected to it. You can see the status of it, whether they're voting, what the signal strength on all of those voters are, whether they're receiving and transmitting, and all of those kinds of things. So a very powerful tool, and it's currently in beta testing in the RMM network, but the goal is to actually open source this as something that's available to the whole ham community. So the nice thing about this is that it provides us a much more detailed view of the entire system than the current AllMons do. And in particular, it integrates the voter information much more in much more detail than what we were able to do with the existing software. And it also, one of the things that we're still working on is the ability to actually add some specific control operator shortcuts to, for example, put the repeater into a certain state. That's still in the alpha stage, so we're not quite ready to talk about that. So that's all I had. Any questions?
Willem, question from chat. Dave WD0HXN asks, does this work with ham VoIP nodes? Does ham VoIP talk?
So I don't see why not, but I have no interest in supporting ham VoIP because they are in violation of the GNU public license. And so I don't want to have anything to do with them whatsoever. So Greg asked, so what's the difference between AllMon 1, 2, and 3 and Supermon 2 and CallMon? So AllMon 1, 2, and 3 and Supermon is basically all very similar. They basically are a PHP interface that all use the same technology. AllMon 3 was a complete rewrite of AllMon and is basically a better technology implementation. However, it doesn't integrate the voter stuff as well. The voter stuff is sort of a standalone component right now. What CallMon does is it's again a complete re-envisioning of how the system works. All of the other ones, AllMon, Supermon, and Supermon 2 are standalone. CallMon is a distributed system and provides more features to manage a much larger network rather than individual nodes.
So it's modular and extensible. It can grow as the system grows and expand.
That's correct, yes.
Cool. Okay, thank you very much.
Glenn asked how much horsepower does that need to run? Not very much. The main thing is that it generates quite a bit of network traffic between the CallMon instance and the Allstar Link instance, because it's constantly polling it to ask for what the current status of the nodes are. So that network traffic, we try to isolate to the 127.0.0.1 interface, so it never leaves the box. But you can run it remotely, and as long as you have the bandwidth, it's typically of the order of about maybe 100 kilobits per second. So not something similar to the audio stream in terms of bandwidth that it takes to actually run a voter instance, which you have to constantly poll. So it runs very well on a Raspberry Pi. We have several instances that run on a Raspberry Pi.
There was a question earlier also from Paul K0WSU about what was the polling interval between CallMon and the Allstar link node.
So for the voter nodes, what we'd like to get is a signal strength sample several times per second. As far as the state of the system is concerned, just polling once per second is probably good enough. But those voter nodes, you want to kind of see how the signal strength varies in real time. So we poll those at roughly a 100 millisecond interval. Well, if there are no more questions, let's take a quick break so people can go and refresh their coffee.